Ever wondered why some AI models chat faster than others? Let's dive into a breakthrough that's rewriting the rules of text generation. Traditional AI models, called autoregressive (AR) models, build sentences one word at a time, like a person typing slowly, waiting for each letter. But there's a new player, diffusion models. These models denoise a whole sentence at once, like solving a puzzle by guessing the full picture first. They're super fast if they can keep up with the math. Here's the problem. Even though diffusion models have the potential to generate text much faster, open-source versions haven't beaten AR models, until now. Meet D2F, Discrete Diffusion Forcing. It's like giving diffusion models a turbo boost. How? Two smart tricks. First, blockwise magic. Instead of processing the whole sentence at once, D2F splits it into chunks. Each chunk can be cached, like saving a draft while the next one starts. This lets the model work on multiple parts simultaneously. Second, guess ahead, don't wait. Traditional diffusion models have to finish one chunk before starting the next. D2F lets them predict the next chunk, while the previous one is still being refined. It's like cooking multiple dishes at once, no waiting for the first to finish. The result? D2F models are 2.5x faster than top AR models like LLaMA3 and Qwen2.5 on tasks like math problems and coding. And they're 50x faster than older diffusion models, without losing quality. This isn't just about speed. It's about making AI more practical. Faster models mean quicker answers, smoother interactions, and more efficient use of computing power. And since D2F is open source, anyone can build on this breakthrough. So what's next? If diffusion models can outpace AR models, imagine the possibilities for real-time translation, chatbots, or even creative writing tools. The future of AI isn't just smart, it's fast. Thanks for watching. If you want to see how D2F works in action, check the link in the description. Stay curious, and we'll see you in the next video. Ever wonder how AI models can solve complex problems faster without losing accuracy? Let's break down a fascinating breakthrough. Researchers tested a method called D2F Dream. Think of it as a turbocharger for AI. By pairing a cache-only strategy, which saves time by reusing previous calculations, with parallel processing, like having multiple workers tackle parts of a problem at once, they achieved mind-blowing results. On a math problem-solving task called GSM 8K response times dropped by 75%, and answers became longer and more precise. It's like upgrading a car's engine and transmission at the same time. Suddenly, you're zooming down the highway instead of crawling in traffic. But here's the real trick. They didn't just tweak the model's code. They adjusted how it thinks, by fine-tuning parameters like block size, how much information the model processes at once, and termination thresholds. When it decides to stop thinking, they gave the AI more room to work without slowing it down. For example, on math problems, the model could generate longer solutions, like taking more steps to solve a puzzle, without becoming sluggish. It's like giving a student extra time to finish a test, while still keeping the clock running. So what does this mean? It shows that even small, clever changes can unlock massive improvements. This isn't just about building bigger AI. It's about designing smarter, more efficient systems. And the best part? These advances could revolutionize real-world applications, from healthcare to climate modeling. Stay tuned for our next video, where we'll explore how these breakthroughs are already changing the game. Thanks for watching, and remember, curiosity is the key to unlocking the future.